Hello everyone, welcome to another video. Today's video is called Physics as a Way of Thinking. So we're going to talk about how we measure distances. I'll start with cosmic distances and move down to microscopic ones. The first idea of how we measure cosmic distances is called parallax. So parallax means that your perspective depends on where you stand. From one side, the mountain might look slightly to the right of a tree. Let's say you have two people standing, there's a tree in the middle. From the other side, you might see the tree slightly to the left, or to the mountain slightly to the left or to the right? Depending on where you're standing. Astronomers use this same trick with Earth's orbit to observe a star from one position in orbit, then again 6 months later from the opposite side. If the star appears to shift slightly against the background of further stars, that's parallax. From this shift, we can calculate its distance. So parallax works well out to about 3,000 light years using modern instruments. Beyond that, the shift becomes too small to detect. So for larger distances, we turn to other methods. One of them is brightness and the inverse square law. So the inverse square law says brightness decreases with the square of the distance. So brightness is proportional to 1 over distance squared. So if you move twice as far from a light, it looks 4 times dimmer. If you move 3 times as far, it looks 9 times dimmer, right? It's the square of that distance. Inverse relationship. Astronauts compare the brightness of known objects, like certain kinds of stars, to estimate distance. This is like comparing 2 Porsche lights. If one looks dimmer, it must be further away. Of course, assuming it's the same kind of Porsche light. Another method is redshift. This is based on the Doppler effect, something we'll explore in future videos in more detail, but for now, you should know that it applies to all waves: sound, light, and even water waves. When a car passes by, the pitch of its engine drops as it moves away. Light works the same way. If a galaxy is moving away from us, its light shifts towards the red end of the spectrum. If it's moving towards us, it shifts towards the blue. By measuring redshift, astronomers can calculate both distance and speed. This is one of the ways we discovered that the universe is expanding. Finally, there are Cepheid variable stars. These are stars that pulse in brightness at regular intervals. The period of the pulse is directly related to the star's true brightness. By comparing the true brightness to what we can see, or to what we see, we can calculate distances. This was the method that Edwin Hubble used to prove that galaxies lie outside the Milky Way. It showed us just how vast the universe really is. Before Hubble, early 1900s, the scientific consensus was that the galaxy was the universe. So his work greatly expanded our understanding of the scale of the visible universe. For distances more relatable to us, distance is comparable to everyday objects we all interact with, we can use measuring sticks or even light to measure common distances. Now, to measure tiny distances, we use tools like microscopes. Microscopes use carefully shaped glass lenses to bend light. This allows us to zoom in on cells, bacteria, and other small structures. For even smaller scales, scientists use electron microscopes. They don't use light at all. They use beams of electrons to see objects at the nanometer scale. Other detectors and imaging technologies can measure things smaller than a wavelength of light. This is how we can see DNA strands, viruses, and even the atomic structure of materials. So whether it's the vastness of the galaxies or the tiniest structures of life, our tools for measuring distance let us make the invisible visible. There's one idea holding all these methods together. Physics is a way of thinking. It's a habit of mind you can carry into work, news, even everyday decisions. So we have model, estimate, invariance, and extremes. Model, simplify first, add detail later. Replace the messy with a clean version you can reason about. Estimate. Don't freeze. Approximate. A back of the envelope answer beats no answer. Invariance. Ask, what stays the same? Energy, charge, momentum. Invariants are anchors in a chaotic sea. And finally, extremes. Test edge cases. If your idea fails when a number goes to 0 or infinity, the idea needs work. So hopefully with model, estimate, invariance, and extreme can help you understand a little bit more, right? Now the last thing here I could say is, how about units? Right, so units let dimensions check your logic. Units are the spell check of physics. So let's do a quick demo. So to see all this in action, let's say someone asks you, how many piano tuners are in Los Angeles? We model the city. We estimate the number of households with pianos, tunings per year, hours per tuning, work hours per tuner, and we land within the right order of magnitude. No database needed, just structured thinking. Having a physics mindset quietly rewires your perspective. News claim about a miracle gadget, you instinctively run an energy budget in your head. Traffic jam appears from nowhere, you think waves and feedback, not bad luck. Cooking pasta, you're doing heat transfer and surface area reasoning. Buying tech, you compare ratios, performance per watt, cost per gigabyte, not just shiny specs. Physics doesn't make you certain. It makes you curious, skeptical, and patient. You stop asking, what's the answer? And start asking, what's the model? What's the scale? And what would prove me wrong? That's the quiet superpower. Not knowing less, but being less fooled. It's a quiet superpower. Physics won't tell you what to think, but it will train you how to think when it matters. So, quick recap. Today we learned about measuring distances from the largest to the smallest, right? We saw how parallax gives us nearby stellar distances. We learned how the inverse square law relates brightness to distance. We explored redshift and how it reveals galaxies moving far away from us. And we discovered Cepheid variable stars, the cosmic mile markers for astronomy. Then we zoomed in to the microscopes and electron microscopes. These let us measure life and matter on the smallest scale. Say whether you're holding a telescope or a microscope, you're using physics to unlock the hidden distances of the universe.